Indefinite integral is a type of solution in integral calculus, which is used to introduce the course. Welcome to Integral Calculus. Before moving on to the next step, let's have a quick review of differential calculus and relate it with integral calculus. With function x, the derivative is determined as the function with dx. Integration is just the opposite operation, so given a derivative, the function is determined through integration by applying the integrand. With these operations, f of x dx is the derivative, and the function of x is now termed as the antiderivative, which is also termed primitive or integral. As a rule and preparation for the upcoming topics in the course, the derivative is also written as differential. The different components of integration is the squiggly s, which we call the integrand. This is the integral sign. X in the model is the variable of integration, and c is called the integration constant, also called the arbitrary constant. There are two types of integrals, first of which is indefinite integral. This is the type which does not have any upper or lower limit. This is also described as the general antiderivative of a function. In the model, the integral of fx dx is f of x plus c. The other type is definite integral, which is a type easily noted with the upper and lower limits. The model of this type starts with the integral of fx dx from a to b, which is equal to the function of b less the function of a. Focusing more on indefinite integrals, let's learn about their general properties. The first states the process of differentiation and integration are just the inverse of each other. In the model, the integral of fx dx is equal to the function of x plus an arbitrary constant c. As a proof, taking the derivative of both ends will result to f of x as equal to the function's prime, where prime is also the derivative of the integral function of x. Integral function is actually the capital F of x. The second general property of indefinite integrals states that the result of integrating a differential will have an additional arbitrary constant, thus the presence of c in the result. Take note that we write it as only the letter c because the derivative of a constant is 0. The basic formulas involved in integration come from the theorems. First, the integral of a derivative is just the function itself with an arbitrary constant c. The second theorem states that the integrand of a series of terms connected by addition or subtraction can be simplified by integrating the terms separately. Say the integral of the derivative of u plus the derivative of v until the derivative of z will be equal to the integral of the derivative of u plus another integral of the derivative of v until the integral of the derivative of z. The third theorem focuses on the constant. It states that if taking the integral of a derivative with a constant, the constant can be extracted out of the integrand. The fourth theorem is called the simple power formula, where if the differential is with an exponent n, its integral is taken as x with 1 added to its exponent. Then it is divided by the new exponent. As a proof, we try to revert back the integration through differentiation. Extract 1 over n plus 1 as they are considered constant. Taking the derivative of the integral with respect to x by using the power rule, we get the exponent n plus 1 times x raised to the old exponent minus 1. N plus 1 cancel out, which then makes the derivative into just x raised to n. An initial example to explain the theorems is to evaluate the integral of 2x plus 3 times dx. With two terms in the differential, use theorem 2 to take the integral separately. So the function becomes the integral of 2x dx plus the integral of 3 dx. With rational coefficients, use theorem 3 to extract them out from the integrand. So the expression turns into 2 times the integral of x dx plus 3 times the integral of dx. The next is to incorporate the simple power formula in the solution. First is to clear out the exponents, which makes the expression 2 integral of x raised to 1 dx plus 3 times the integral of x raised to 0 dx. Then work with the integration of the first term. That would make 2 times x raised to 1 plus 1 upon the exponent 1 plus 1. The second term becomes 3 times x raised to 0 plus 1 over the exponent 0 plus 1. Then add the arbitrary constant. Simplify the whole expression to have twice of x squared over 2 plus 3 times x raised to 1 over 1 plus c, where the 2 on the first term cancel out. So the integral of 2x plus 3 is x squared plus 3x plus c.